Hello everyone, this is another video from Easy Electric series, and today we want to learn about other peripherals which we have in the microcontroller, which is the phase locked loop, or a PLL. So what is the PLL? The short answer is PLL allows to us to speed up or slow down the clock or the frequency of your microcontroller. So what you should be careful whenever you speed up the clock, so definitely you are using more power. So that means usually it is trade-off between speed and power. So if you use that in high speed, you need to more power, and if you slow down the clock or decrease the frequency, you save a lot of power in your system, specifically if the power is the important factor in your application. So let's take a look to the PLL registers and see how we could initialize or manipulate these registered bits to somehow speed up or slow down the frequency, the bus frequency that we have in the microcontroller. So we take a look to the two important register, the RCC, RCC2. So again, for this level, I'm not going to go with deep on these register. Just what I try here to show, give you a basic idea to the beginners that they learn how you could change the frequency of the microcontroller or the clock with using the PLL registers. So that's what I focus on these two. So on RCC, I focus on the bit. The RRCC is one of the registers, PLL registers. So the most important bit is 10 to 6. So here with adjusting these 5 bit in these registers, somehow you are telling what is the external clock for your PLL. So if I take a so if I could okay, if I take a look to the data sheet that we have, so you go to the first page, search for RCC. So this is, let's see, I'm looking for RCC, which go down. No, it's actually need to go down here. RCC, yeah, this one. So if you take a look to this XTL, which is the most important bits that we have. So again, I'm not going to talk about the others because the other is just one time initialization. So that means you one time put that numbers, you initialize your PLL, then next time whenever you want to change the frequency, you don't need to touch them. So I'm more talking on the or focus on the bits that we need to make changes whenever you want to use in any frequency. So XTL is 6 to 10. So if you back here bit to 610 and see what is doing XTL to 10 is this 6 to 10, and with putting any of these numbers, so it somehow is the crystal value, this field specify the crystal value attached to the main uh, oscillator. The encoding of these field is provided below. So frequency that may be used with the USB interface are indicated in the table. So what it tells us, it tells with putting any specific bits, you could actually have or use any specific crystal value in your PLL. So what we use, we initialize in all cases in we put 10101 here, which somehow tells our external clock is will be the 16 megahertz. So what is these numbers? So if you consider these 4 bit, this is 5, this is 1. Technically with writing the 15 here, we are telling our PLL external clock that uses 16 megahertz. So back to here, so 115 is telling the same thing that I mentioned. So we are giving 60 megahertz actually external clock. So again, if you want to have the different version of that, so we are not changing that. So let I bring this back here. So that's what we have. Even the code you see, we write 10x15, which means we are telling external clock should be 16 megahertz. So the other important one is RCC2 register. So again, the most important one is bit 20 to 28. So here is the 7 bits. You could actually write any number between 4 to 100, 127. So whatever you write here, you consider as an N. This is a place that if you want to increase the frequency using the PLL here, you should actually write the right N here, okay? So there is a few table. It is a little complex. You could read the data sheet, but we find the formula which somehow it make your work most simple whenever you want to change the frequency of your microcontroller using the PLL. So see, whatever you write here, you consider that as an N. So that means the clock, the PLL clock, or the clock that you set up with the PLL is 400 megahertz divided by n plus 1. What is the n? N is the number that you writing here in bit 20 to 28. We call that n. N is the number in base 10. For example, if you write this bit pattern here, which is 40120, technically this is base 2 in base 10, this is 4. Back to this formula, clock should be 400 megahertz divided by 4 plus 1, so which is 5. So that means if you write this number, the clock or the frequency that you use will be the 80 megahertz. Okay, so let's see, if you want to change the frequency to 50 megahertz, what should be the n, what you should write here? So the answer is 7, right? If I write the 7 binary here, so 400 divided by 7 plus 1, which is 8. 400 divided by 8, you get 50 megahertz. So if you want to change to the 20 megahertz, what we should write here as an N? So definitely around 19 should be fine. So if I write 19 here, so I have 400 megahertz, 90 plus 1 is 20. So it should be 400 divided by 20, so which give me a 20 megahertz. So that means the only place that you are going to change is these SysDIV bits if you want to get different frequency with your PLL. So if we focus on the codes, as I mentioned, in the next video you will see how we could somehow use SysTech timer, PLL, adjust the frequency, and then use the SysTech timer to make any delay that we want. But here again, I want to focus on the PLL and show you which specific register you should use. So see, these are the 3 registers that we have here for the PLL. So the RCC and RCC2 is these 2 registers. So here see the address, we give these 2 name, then we initialize them with this name, not using their address. So as you see, you should have the function to initialize that. So here you see you should follow these steps, which is the few steps to able to use the PLL. So the almost all of these line is just one time setting. So that means whatever you see here, you do the same number just for changing the frequency. You should actually work on just change these line and these 4 that you see, which is somehow is these sysdiv2. Okay, so the rest, if if you want to move from one frequency to other, you just have exactly same. Nothing changed here, just you change these number that you see here. So again, I don't want to go deep on this because here again, I want to make this video for the beginners and show them how easily they could use the PLL with changing just one value here. They could get any frequency that they want. So again, the whole detail is on the datasheet. You could take a look. So what you should do in the beginning, if you want to use the PLL, first the RCC2, you need to write these values so that all of them explanation is on the data sheet. It's actually telling that you are going to use RCC2. So the next you put these value inside again the RCC2, somehow you bypass the PLL. So then you have this line with these two value, which is somehow it's clear the XTAL field. So then you are writing the 115, which as I mentioned before, which somehow you configure for 16 megahertz crystal. Okay. So which is these, it is the same thing that I explained here. So even whenever you want to change it, don't touch this. This is keep that on the 16 megahertz, but changing this value, you could get any frequency that you want. So that's actually the other things that we mentioned. Again, this one is just one time initialize one time. So whenever you want to change, you don't need to touch them. So the next you actually put this value here in the RCC2 again. So it is actually configure the main oscilloscope source. So then you write this inside the RCC2 again. It's active the PLL by clearing the PWRDN. So the next you write this value inside this RCC2 again. It's actually set the DSR system divider, somehow use the 400 megahertz PLL. So then you have this line, which is this is the only line that you need to change if you want to change the frequency. So what's happening in this line? Again, it is RCC2. It's first it's and not of these values. So if you take a look, it technically clear the system clock divider. So these ending with this value, you could write these in binary, and what you will see it exactly clear, or put the 0 here, bit 20 to 28. So then this one, it says you write 4, which is 0 1 0 0. Then this is shift to the left to 20 2 bits. So you have 4, which is 0 1 0 0. Then shift that 22 to the left. So what's happened technically, it is writing the 4 here because this is bit 22, right? So if you have 4, shift that 22 bit, somehow you write the 4 here. So if you write the 4 here, based off this formula, what you adjust the clock will be 80 because 400 divided by 4 plus 1, it is fine. So you adjust these to the 80 megahertz. So that means in this line, you somehow, with changing these number, you could adjust the frequency that you want. So that means in this function, you could use exactly the same function. Don't touch anything. Anytime that you want to adjust the PLL, just change this number, which is somehow back here, and change these SysDIV2 that you have here. Based off this, you could actually get any frequency that you want. And the next line, which is this while that you see, it's wait for the PLLRIS bit, and finally you write this number inside .rc2 again. It somehow enable use of the PLL by clearing the bypass. So if you want to get any other frequency, so you just use the same thing, don't touch any of them. The only line you need to change for changing the frequency is these 4. So again, use these formula for see which end do you want. So then you just change these 4 to that number. For example, if you want to get 50 megahertz, just change these to 4 to 7 because these, based off these formula, if this is a 7, So you should actually get 50 megahertz. So if you want to get 20 megahertz, just comes here and change these 4 to 19. Why? Because you are writing here 19, and based off this formula you are giving you 20 megahertz. So again, this is the way that I explain that to the beginners, and I think it is I don't want to overwhelm you in this level. So, and I just want to show you the simple way that you could use the same thing, use the PLL, and the easy way with just changing these number that you see, which is somehow change the SysD IVDs bits that here you could get to any frequency that you want. So that's actually is about PLL. So in the next video, I'm going to somehow combine the all last three videos to show you how you could actually use all of them, PLL and System Timer, and make any delay that you want. So I hope you find this video useful. Thank you for watching this video.